I'm ready.
All right. Chapter 4, I'm going to just kind of talk a little bit while you copy this down and get caught up. I think you'll probably be able to multitask that way. So algebra, chapter 4 is linear equations. Word linear, whenever it's linear, it's what kind of graph? It's a graph of a line. So there's all kinds of words in linear. If you look, you can probably find at least 6-7 words in there. But line is the one we're focusing on. This whole chapter should be lots of stuff about lines, graphing lines, equations for lines, filling in data tables that if you put the points on a graph, it'd give you a line, something like that. 4.1 is understanding two variable relationships. There's tons of situations that involve two variables. You think of like science, whenever you do like an experiment, typically you have your manipulated variable, your x value. It's like, well, if I change this, what happens to that? So you're looking at two things, an x and a y, two variables. So this chapter is really pretty important. It comes up in tons of different ways. If you were to look and try to come up with like equations for some of those, and I'm just going to write some of this down, but I probably would skip it if I were you. But let's say you're getting paid $8 an hour. If you wanted to say, all right, how much I'm going to make, if you're getting paid $8 an hour, how would you combine 8 and like h being number of hours you worked? If you have like $8 an hour, so if you're getting $8 an hour, if you're not sure how to combine the 8 and the h, a lot of times it's easier if you think about like real numbers for h. So if you work 1 hour, how much are you going to get paid? Yep, so if you work 1 hour, if h is 1, you get $8. If you work 2 hours, you're going to get 16, right? Those make sense. Well, then you could say, all right, what do I do to 8 and 1 to give me 8? Well, if I multiply, that gives me 8. 8 times 2, does that work? Yup. You know, because sometimes the first one will work for like addition, but the second one won't, or something like that. So you know it has to be 8 times the number of hours, right? And that's how you get this 8 times h. H is the number of hours. Don't be afraid to put in numbers to see what to do to the variable. Roman numeral 1, filling in data tables. And I wouldn't write out this whole example. I figured I'd put it in there and then we could like make an equation from there and then kind of do our magic. But you don't need to write out what the equation really stands for in your notes. But filling in data tables, the key to filling in data tables is put numbers in for x, which will be the independent variable. So put numbers in for x and find y. Where x is going to be your independent variable. You know, maybe it won't be x and y, maybe it'll be two different things, but they're going to put one number in the equation and then figure out what the other number has to equal. Okay, first example. The average weight of a married male is 170 plus 2 pounds per year that they're married. And say weight equals, well, after 1 year, the person's going to weigh how much? 172. After 2 years, they're going to weigh 174, then 170. So every year we're going up by 2, right? So to degree we could do 2y. So 2 times the number of years, and then plus the starting weight. You can see where a lot of people maybe would say 170 plus 2w. That's totally fine too. But then if we were to take and make a data table, because that's the whole point of this section, y in this case is my independent variable. It's over here on the right side of the equation. W is by itself, so that'll go in the bottom row. That's the dependent, because the weight of the person depends on the number of years they've been married. And I'll make some different lines. That's probably more than enough. And we'll put in 0 years. You said after 0 years, a person weighs 170 according to this equation. After 1 year, the person will weigh 172. 2 years, they'll be, let's jump up to 5 years. After 5 years, now it's going to be 2 times 5, right?
180.
Yep, so this is 10 plus 170 gives us 180. Nice job, Abby. And then if we maybe do like a 25 years, 2 times 25 is 50. We're just taking that 25, we're putting it in for y. So we have 50 plus 170 is 220. And then 50 years, their golden anniversary or whatever, they're going to end up weighing how much? 2 times 50 is 100, plus 170 is 270. Pays $8 an hour. You can skip that if you want to. But if you're getting paid $8 an hour, you could say P equals 8h or 8x or something like that. If h is the number of hours, if you're getting paid $8 for each hour, it'd be something like this. Does that seem to work for you? So then we could take and make our data table. What goes in the top, H or P?
P, H.
H. The independent variable always goes in the top, and the independent variable always, pretty much always, is going to be like over here with other numbers. And it'll be solved for the dependent variable. So P and H, and we could throw in some different numbers. Maybe let's do a 0 for our first time. If they work 0 hours, they get paid 0. If they work for 1 hour, they get 8. Work for 3 hours, they make 24. 10 hours, you get 80. And I don't know, let's say 40-hour work week. Then they make 8 times 4 is 32. And then you throw the 0 on the end. Roman numeral 2. So getting an equation from a data table. In this we're trying to do what we just did, but backwards. We're trying to say, okay, here's a bunch of data and 2 variables, and we need to figure out what's the equation that will give us all those numbers that are in the data table. So my first example, I'm just going to say find an equation. I'm just going to do EQN for equation 4. We're just going to start out with an x and a y. If I read across my top row, I have 0, 1, 2, 3, and 5. So 0, 1, 2, 3, 5. My bottom row for my y values, I have 0, 7, 14, 21, 35. How I look at it is this. The zeros really kind of do us no good because they don't really tell you what's going on there. But I'd start right here with this 1 and this 7. And I'd say you could get from 1 to 7 by either, you're going up, so it's probably either going to be addition, adding 6, or multiplication that you're multiplying by 7, right? Whichever one is true there has to be true for 214 and 321 and 535. So if you do the 2 plus 6, do you get 14?
No.
Nope, you get 8. So it shouldn't be this plus 6. And this is where you hope like crazy that the times 7 works. 2 times 7 is 14. 3 times 7 is 5 times 7, 35.
Wait, what if it doesn't work?
Then we go back to the drawing board. So we'll deal with some uglier ones soon. Maybe say that. So y equals 7x. It's going to be the equation. And that would also work for the 0, 0. Because if you do put a 0 in for x, 7 times 0 gives you the 0 for y. The next part is going to be where things start getting a little bit dicier. So I wouldn't start coasting quite yet because they're going to get a little bit more challenging. I'm going to put a little star and try to say this. If y goes up by the same amount each time x goes up 1, so if y, maybe I should say changes, because it could be going down, by the same amount, each time x goes up by 1. The equation will have, and this will probably make more sense when we do some examples, y equals that amount times x in it. So if y changes by the same amount each time x goes up by 1, the equation will have that amount times x in it. And that's probably not insanely clear yet, but if we do a couple examples, I think that'll help kind of clear things up. So I want to do 2 or 3 examples. So my second example in this section, I'm going to have an xy chart again. My top row for x's are going to be 1, 2, 3, 10. 1, 2, 3, 10. My y values will be 5, 6, 7, and 14. This first one, we could say we're either going up by 4 or we're multiplying by 5, right? Which one of those works for my 0.26 and my 0.37 and so on? Plus 4 works. The times 5 doesn't, because 2 times 5 would give me 10 right there. So we know it has to be, for an equation, y equals x plus 4. Nice job, Jake. So y equals x plus 4. Now, I want to kind of point one thing out here that's going to come in handy in the next section. When x goes up by 1, y is going up by 1, right? X goes up by 1, y goes up by 1. If we had to put a number right here in front of x, you agree we could put a 1x right there, and it wouldn't change it any. Wouldn't be simplified, but it still would give you the same answers. So when y goes up by 1, when x goes up by 1, it's like 1 times x. What I was trying to say before, if y changes by the same amount each time, so y goes up by 1 every time x goes up by 1, the equation will have that amount times x in it, even though we also have this plus 4. Now let's jump to example 3, and we're going to kind of combine a couple things in example 3. So we have our x and our y. I'm going to do 4, 5, 6, 10 for my x values. 4, 5, 6, and 10. And under the 4 I have 17. My next y value is 22, then 27, then 47. So I'd start that same way, let you finish copying it. So I'd start by saying, how do we get from 4 to 17? And you could add 13, right? 4 plus 13 is 17. Or you could multiply by, that doesn't work out nicely, the multiplying, but it's going to end up being 4.25. You could do 17 divided by 4. If you don't see it, you come up with 4 1/4. So now if we're looking at this next thing, the 5 to the 22, 5 plus 13, that's 18. So that's not going to work. So it can't be plus 13. 5 times 4 1/4, that's going to give me like 21.25. So that doesn't work either. So what we'd been doing, we're kind of sunk a little bit, yes? So when you get something like this, that it's not just a straight x plus this, or x times this, or x minus this, you need to kind of bring out the big guns. So we'll get rid of this. And now we need to start looking for patterns. Well, here, x is going up by plus 1, right? And here, x is going up by 1, so plus 1 and plus 1. Still good? How much is my y value going up each of those times?
5.
That each time it's going up by 5, right? So we have our pattern. If we're going from our 6 to the 10, that's not going up plus 1 anymore, right? That's going up plus 4. So if that's going up by 4, can anybody in their head say how much this should go up? Should go up 20. But if you don't get that, we'll come back to it. Don't worry about it. But if y goes up by 5 every time x goes up by 1, if we jump back up here, if y changes by the same amount each time, y changed by 5, right? Each time x goes up by 1, the equation will have that amount, the amount y changed is 5, times x in it. You with me? Because every time we make x 1 bigger, y needs to get 5 bigger, right? The only way to do that is going to have y equal 5x. Now, every time x gets 1 bigger, y is going to automatically be 5 bigger, because you just multiplied by 5 one more time, one more x value. But if I do 4 times 5, or 5 times 4, if I take my x value and put it in there, I don't get 17, right? I get 20. 5 times 4 is 20. What do I need to do to 20 to change it into my 17?
Subtract 3.
Subtract 3. Yes? And now we hope like crazy that works for the other points. So if it doesn't, then it's like, okay. So if we take our second point, we put this 5 in for x. So 5 times 5 is 25, minus 3. Yes. Then you do 5 times 6 is 30, minus 3, 27. 5 times 10, minus 3,
47.
and you're like, cha-ching, you got it. But a lot of it for these, we'll do one more and then we'll be done. A lot of these are just, you just got to kind of mess with it a little bit, massage it till you get it to do what you want, or as my physics prof in college would say, bludgeon it into submission. So very last one. So if we were to pick, should we do x and y still?
Let's do J and B.
J
No,
and B. We have no idea what those stand for.
Jelly banana.
Yeah.
Yes.
And here I thought it was Justin Bieber. So my y value is 16, 22, 28, and 40. All right. Is my equation going to be J equals something or B equals something? B equals. Because it's always going to be the y value equals something, the dependent value equals something. And if we go back to kind of the steps we were doing before, 3 plus 13 gets me 16. Wouldn't that be nice? 3 times 5.3 repeating will get me the 16. So now if we take our 14, or our 4, so now 4 plus 13 gives me 17. So we know it's not this, right? 4 times 5.3 repeating is close. It's going to be 21 and 21.3 repeating, I think. So, but it's not the same, right? Okay. So does this tell me you know what's going on?
Can I say the answer?
How about you give me the first part of the answer?
B equals J times 6.
Okay. So how's he getting that? We'll stop there. I'm going to do 6J. Usually they write a number before a letter if it's multiplication, but yeah, you totally see what's going on. So my X values are going up by 1 in those two spots, right? And he sees that my Y values are each time going up by 6. So I have a plus 6, a plus 6, when the X's are plus 1 and plus 1. So it has to be 6 times J. Then every time J gets 1 bigger, my B values are going to get 6 bigger. Still good? Then the last step, if I do my 6 times J, what do we need to add in here? What's kind of like our correction? So 6 times 3 is 18.
Yeah.
So then we have to do what to get 16? Minus 2. And in a perfect world, you'd go through and you'd actually maybe check some of those to make sure you're right. So you could say 6 times 7 is 42, minus 2 gets you 40. 6 times 5 is 30, minus 2 gets you 28. But that's the equation. Should you write out something like find this first and then figure out the correction factor? Okay. So find rate of change and then figure correction. So if you want it,